So regardless of faults in communication, I think that Asaf transcended very well, and I want to thank you for taking us into the application called human being. So I want to invite our last speaker for this session, and our last speaker is Opher Doron. Opher assumed the job of general manager for MBT Space Division in September 2011. MBT is a part of Israel Aerospace Industries Limited. So Opher served in the Israeli Navy, and now he's in space, but he came from the Navy. For us, people who are either associating with the ground, with the air, or with the sea, it is a major transition, I must say. He was in the Navy from 79 in command and staff posts. He commanded several missile boats, including SAR 5, Corvette, and Squadron. In his last position, he headed the Operational Requirement Department. Opher retired from the Navy as a captain in 2002 and still serves in the reserves. From 2003 till 2008, Opher was director of marketing of MBT missiles, and from 2008 until 2011, headed the Technical Systems Division at NEST TSG. Opher holds a BA in economics with honors and an MBA from Haifa University. Haifa is close to the sea. Opher, please.
So they asked me to speak about beyond the internet, and I thought, how far could we go beyond? And space is pretty much as far as we can go. So we'll talk a bit about space, and then a bit about cyberspace, and then a bit about how cyber can be used against space. If I can make this work. Does this make it work? Something should make it work. Okay. מישהו יכול לגרום? זה לא. מישהו יכול לגרום לזה לעבוד? אני עושה. כן. לא, עכשיו אני כבר גם בלי מצגת פה. Okay, so we're extremely dependent on space in our everyday life. You may not know it and feel it all the time. You all know you've got GPS, and some of you navigate by Waze, but lots of other things come from space. You know what the weather's going to be because we have satellites up there. Your maps that you navigate on come from space. Many of you communicate using satellites, even though you don't know it. It's not just your TV, it's the phones that you talk on. In many regions of the world, internet can only be delivered by space. You're never going to get fiber optics to far-off regions of small countries like the United States of America in the middle of Iowa or Russia or China or Africa. So space is crucial for almost everything that we do nowadays. Space is an unpleasant place. Satellites have a difficult life. It's cold and hot. There's vacuum. It's difficult to do the thermals. There's radiation that wreaks havoc with electronics and with software. Distances are huge. Orbits are fast. And after you spend hundreds of millions of dollars building a satellite and thousands of people or hundreds of people work on it for a few years, you put it up on this huge explosive device called a launcher, and set it off and hope it doesn't blow up on the way to space. So you invest heavily in making a satellite work. Satellites are very sophisticated, but very conservative at the same time. All of you have updated the software on your computer. Most of you have crossed your fingers hoping that it would reawaken when you finish doing that. Now imagine doing that to your satellite in space and hoping it reawakens. Israel decided to get into space in the very beginning of the 1980s. It was a crazy strategic decision at the time. In fact, it would be considered crazy by many now as well. We're the only small country in the world that has full capabilities in space to build and to design and to launch and to operate satellites. The others are all huge, Russia and Japan and America and Europe and China, of course. So it's a big deal for a small country to go into space. It's probably one of our most successful startups. Now, we've become a pretty large startup since then. It's become a big business. The space industry is about $1 billion in Israel now. Satellites are a few hundred of those. We're sort of going back towards startups. We're actually starting off a small Hamama startup center for space technologies soon to get some more startup entrepreneurship in there. But space is a daring thing always. And for Israel, it's a strategic decision so that we could look and talk far away and see what the bad guys were doing all over our very, very challenging and interesting neighborhood. And since we started this space program, we have launched 15 satellites that have been performing fantastically. You can't do everything when you're such a small country, so we're specialized. We do very high resolution, very small satellites for Earth observation. So we basically take pictures from a few hundred kilometers away. Satellites, observation satellites fly at about 500 kilometers altitude, and take pictures with fantastic resolution. So you can see people, you can see cars, you can see buildings, you can see the bad guys doing what they want to do. We're getting better and better at resolution, and we keep them very lightweight. So they're relatively cheap and relatively cheap to launch, but also very agile, so you can take pictures wherever you want to look at them. It's very important in space. And because the bad guys like working at night and they like working under the clouds, and we also have radar satellites. Radar satellites can take a picture that's very similar to an optic picture, but they take it through the clouds and through the dark. It looks slightly different, but it's enough to tell us what the bad guys are doing day and night. And we've got some of those up there as well. We launched them the wrong way around. You've all learned in Bible class why Moses decided to pick this place after 40 years wandering around the desert. It's the wrong reason. He chose this place because this is the one and only place in the entire region where you have 2,000 kilometers of open sea over which you can launch a satellite and drop off boosters without getting the neighbors worried. The only problem is you have to do it westwards. And everyone in their right mind launches satellites eastwards because that's the way the Earth rotates and you give it initial speed. But there's a theory that if you launch eastwards, it'll cause some problems. So we do it westwards. We also develop, build, launch, and operate, well, we don't launch them, but we operate them, the communication satellites. These are much bigger ones, and they're further away. They're 36,000 kilometers away, so I think that's pretty much beyond the internet, although much of the internet does go over communication satellites. The largest one we're building now is called Amos 6. It weighs 5.5 tons almost. We'll be launching it in a bit less than a year. We're actually going out towards smaller satellites that are smarter. And it's not trivial making smart communication satellites because communication satellites, whilst being very, very sophisticated, try to be transparent to the users. You spend a few years deciding what your satellite's going to look like, and then a few years building it, and then you launch it. It has to live for 15 to 20 years in space. You can't fix it or anything. So the operators, who are now buying a several $100 million satellite for 20 years, want it to do its job in 20 years. Can you predict what communications are going to look like in 20 years? I doubt it. So satellites are pretty stupid. They receive and transmit back down again without understanding, without doing any processing of them. we're actually starting to do processing up in space. We've got a couple of space processors up on our communication satellites, and we're going towards smart processing on communication satellites, where you're actually going to be uploading applications to the satellites. So that's sort of an Internet of Things stuff, when you start uploading applications to satellites 36,000 kilometers away that you can never reach. So if satellites are so important and so sophisticated, somebody must want them out to work. So the bad guys have been trying to take care of satellites more or less since satellites started working. And the first thing people say is, well, can we shoot them down? And the answer is yes, but it's very difficult, and it's quite unpopular. It's unpopular because when you blow up a satellite, you get thousands of satellite pieces floating around in space, and those pieces can start running into other satellites and colliding with them. And when you're traveling at 7.5 kilometers per second, if you get hit by a small piece, it's end of story, and then you get thousands of other pieces. So space debris is a big problem. People don't like it when you shoot down satellites. The Chinese did it in 2007 against one of their own satellites just to see if they could and to show the world they could. And the US had a faulty satellite of their own that they shot down in 2008, just 1 year later, from a Navy ship. So they showed everyone they could, and they're probably not the only ones. And theoretically, you could fly up to a satellite with another sort of satellite, for instance, one designed to refuel it, and grab it and take it away and move it from its orbit. But that's really difficult, and it's also very, very expensive. It is easier to interfere with satellites. So interfering with communication satellites is extremely popular in this region, for example. Everyone's doing it. The Iranians very obviously block all sorts of propaganda coming from the US and from BBC and from any other radios. The Libyans are blocking satellites, or jamming satellites, and Eritrea is jamming satellites. Chinese are jamming satellites, and there are even press reports, God forbid, that said that Israel put on propaganda during the 2006 Lebanon war and Hamas channels or Hezbollah channels. So maybe we do it as well, I don't know. And you don't even have to go to the Middle East to see that. Someone jammed the Playboy channel in the US a while ago because he was a Christian, devout. So it happens everywhere. And you can probably blind observation satellites, although it's not so easy to do, and jam stuff. But this is all for the experts. It's not, you need big equipment, big antennas. Once you get caught, it's unpleasant. So there is another way in, and the other way in is cyber. So that's why I'm here today. At the end, apart from the computers up on top of the satellite, there are large ground stations with tremendous infrastructure. These do everything from controlling the radios that talk to the satellites and decode and encode and send them commands, to the stuff that's transmitting to the satellites with the actual information that's going up and down. And then it goes from there to data storage and to data distribution and to sending the TV signals everywhere and to customer CRM systems, et cetera. So you go from very specialized equipment all the way down to mundane storage and internet stuff. And if you take out the ground control system, then you're starting to make some interesting headway. So there's been quite a lot of activity in cyber. It's not talked about very often because space people are sort of closed. They don't like talking about their vulnerabilities very much. But there are reports from the US that in 2007 and 2008, somebody interfered with a couple of the NASA satellites using by hacking into a ground station in Norway, somebody allegedly being Chinese in origin. And just about 2 months ago, General Hyten, the commander of the US Air Force Space Command, which is also the Space and Cyber Command, said that, and I quote, outside groups from around the world are constantly targeting the satellite networks of the US Air Force, accounting for millions of probes every year. So somebody's trying to fool around with the networks there. He's got a small cyber force of his own. He's got 4,600 cyber people and another 10,000 reserve ones. That's what he writes on his website. So I don't know how many they really have. So if it's such a lucrative way of getting in there, you have to deal in protecting it. And cyber protection of space assets is something we've started dealing in very seriously over the last few years as the risks have become clearer and clearer. It's a huge challenge because you're dealing not only in the normal routine IT stuff, but also in dedicated equipment and embedded controllers and RF devices, and they're all distributed all over the world because I've got stations in several different countries around the world talking to my different satellites, and they've all got specialized equipment, and you may have to fool around with the software in space to do it well, and you really, really don't want that software to go offline for a while because it's unpleasant to have your satellite up there when you can't control it. So you've got to do extensive testing. It becomes very, very complex in order to do all this and connect all these proprietary systems and protect them without the problem. So we've been coupling our space expertise with our cyber expertise, first off to protect our stations and then to start working with other potential satellite users to work on their systems as well. And it's a layered approach where you deal with the IT and the communications, and then you deal with the dedicated satellite stuff and hardening every type of equipment specifically, and finally you go on to the sophisticated stuff and anomaly detection and situational awareness, et cetera, et cetera. So it's a growing business. More and more satellite operators are becoming aware of it, and we're hoping that we manage to stay in front of the trend. It's a huge, huge, huge challenge, especially with systems that have to live for so long and are so very, very sensitive to off time. Thank you very much.
So I just wanted to thank Opher and to thank the speakers of this session. I think it was one of the most interesting sandboxes to discuss cybersecurity and to stretch your mind a bit. So we'll see you next year, I suppose. And in the meantime, protect yourself well. Bye.